All right, we're going to talk about area between curves some more. And I want to look at an example here. I want to find the area between these two curves. Or maybe between these three curves. I don't know. Let's see. All right, let's take a look at this one. My first function, f of x, is x squared plus 2x plus 1. And my second function is g of x equals 3x plus 3. And I've got more functions between x equals -2 and x equals 4. So I would like to find the area bounded of all the enclosed areas bounded by these lines, curves. So the first thing that I'm going to want to do is sketch a graph of these functions. So in order to sketch a graph of these functions, this shouldn't be too difficult. I can just use a graphing calculator, but I'm not going to. I know that these two are easy for me to graph. This is a vertical line at x equals -2. And this is another vertical line at x equals 4. So this bounds the region like beginning and end. And this one is easy. This is a line, so its y-intercept is going to be at 3, and its slope is 3. Instead of going up 3 and forward 3, I guess, or forward 1, I could do that. Forward 1, and then down 3 and backwards 1. So basically it's going to look like this. So if I extend that line up, so far I've got this kind of mess here. And now I need to put the graph of that parabola in. Well, that parabola actually, what I notice is that this factors as x plus 1 quantity squared, because 1 times 1 is 2. Or 1 times 1 is 1, and 1 plus 1 adds up to 2. So I can factor that. It's x plus 1 squared, which tells me that the vertex to this function is the vertex would be at -1, 0. So the vertex to that parabola is at -1, 0, or -1, 0 this way. Well, that's right here. I can't seem to find a point right in the right spot. So it's that one right there. And then if I put in 0 to that equation, I get 1. If I put in -2, I get 1. If I put 2 into that function, so far it's looking like this. Okay, if I put 2 into that function, I get, what do I get? 9. Oh, that's 1 in, sorry. If I put 1 in, I get 4 first. And then if I put 2 in, that's when I get 9. All right, so kind of looks like this. All right, and my graph is by no means perfect. I'm not going to be able to tell a whole lot from here. But here's what I can tell. I've basically got 3 areas. I've got this little area right here. I've got this little area right here. And then if I were to extend this way up, I would have this little area right here too, I think. And if you actually get on your graphing calculator and type all of these in, Okay, so this is at least the parabola in that. So you can see that like this extends, there's more over here, and if you had that vertical line at 1, 2, 3, 4, that there would be another little section over here. So we basically have 3 little areas to find. So how many integrals are we going to have to set up? 3 of them. We're going to have to set up 3 integrals. So let's deal with this thing first right here. So this would be the integral from where to where? Along the x. We're just dealing, everything's an x value, so we only look at the x-axis from -2 to -1, from -2 to -1. What is the top function here? The parabola. So x squared plus 2x plus 1 minus, what is the bottom function? 3x plus 3 dx. Okay. So now the middle integral will be the integral from where to where? Yes? It does. We took care of that right here with this limit of integration. The vertical lines in the problem end up being limits of integration for that. All right, so the next one, where does this little section start? At -1, okay? Now, here's my deal. I can't really tell from my horrible graph where it ends. So what I need to find out is where does this line meet this curve? How do you find out where this line meets this curve? Okay, put it in the graphing calculator and look at that, yes. How could you do it algebraically? Set them equal to each other. Okay, we want to know where are these y values equal to each other. So I can set these equal to each other. These are not short problems, okay? These are not, the concept itself of finding area between curves is an easy concept. Top function minus bottom function. Right function minus left function. The process of working out an entire problem takes time, and it takes a lot of algebra. It's pulling in a lot of skills. Actually, if any of you wanted to retake the ACT, I mean, how many of you are still taking the ACT? Okay. If any of you considered retaking it or, you know, taking it, this calculus, you'd be surprised at how much algebra it's forcing you to review, and probably how much better you'll do on the math portion because of that. Of course, you could overthink everything, but I doubt it. But anyways, okay, so get this equal to 0. I'm going to subtract 3x and subtract 3. So x squared minus x minus 2 equals 0. I can factor that. So these two functions meet when x is 2 and when x is -1. Okay? We already knew that they met at -1, right? Okay, but we want to know, okay, they meet at 2 then, right? So the upper limit here would be 2. So in this little section, what is the top function here? The line is minus the parabola and finally for the last section, okay, we're going to have to do a little more of this stuff here. We know that it's going to start at 2. Basically, I'm trying to find one continuous, you know, it's 3 little segments, but they're all connected. So like the end of this integral will be the beginning of the last one that we do. Now we need to find out where this line meets either, well, never mind, we don't need it. What is the ending of it? 4. Okay. We don't need the y values. So in this section, what's the top function? What are your options? Here it is right here. What's on top there? It's the parabola's on top. The vertical lines are part of the limits of integration. So the top function is the parabola minus the line. So you have 3 integrals to work out. Now, which 2 of them will be exactly the same antiderivative? The first and last. Okay? And actually all you're really going to have to do with these, I mean, I wouldn't try find an antiderivative super fast. You know, combine the like terms, add the opposite of each part. This is actually the integral from -2 to -1 of x squared minus x minus 2. So then this would be the integral from 2 to 4 of that exact same thing. Okay, this one, you're going to have, let's see, you're going to add the opposite of each of these. So you're going to have the integral from -1 to 2 of 2 plus x minus x squared dx. So if you found this antiderivative, you found this one, and you can just plug the limits in. Top minus bottom. Are there questions up to this point? I may not finish this example because the rest of it's just antiderivative and plugging numbers in.